So yeah, we're just gonna drop down a geonode again, and we're gonna call this squid thingy. We just call it squid. It's not a squid, I know. It's definitely not a squid, but it's still something that resembles a squid, maybe. So we just drop down a sphere, and we call it base. And this sphere, just gonna do like that. I don't like seeing. Doesn't matter, but yeah. We're gonna drop it as a polygon, and we're gonna up the frequency a lot, 200 maybe. We're gonna give this normals, and we're just gonna have that, and we're gonna do a point VOP, and we're just gonna deform this a little bit. So basically what we're gonna do is just gonna give it some bass noise. It's very straightforward. I think like the cellular noise is a good option here. So what we want to do is just keep the dynamic simulation on. Just gonna drop on a unified noise and use static because it's faster, I think. And what we want is Verdi cellular f1 minus f2, and then just to make it a little bit random, we're just gonna bring down AA noise, and we're gonna fit that. Or first of all, we're gonna lower the frequency a little bit. We can visualize this if we want to. Plug it into CD, classic option, and as you can see, it runs quite low. So we're gonna refit it, and we're just gonna say something from minus 0.4 to plus 0.5, and we want the high destination, so we want to say 2.4 and 7, and we want this to be a 3D noise, sorry. And then this is going to the position here. No, sorry, this is going to the frequency, sorry. It's going to the frequency, and for position, we just want to bring in the straight up position. So we have a little bit varying frequency. If we look at this, we're gonna drop down a modulus. Put that. We're just gonna see we have. We're just gonna have a fractal as well. Standard is fine. Bring down the roughness a little bit. 7, 1.8 maybe. And this modulus we're gonna fit. Sorry, I'm just doing this, but not really explain because this is not the important thing. It's just 1.65, 0 point, very low number. Let's say like that. And I also gonna bring in. We can just, if we just look at this, this is what we have at the moment. And we could make it a little bit more random, so we can bring it in. We're just gonna bring in another AA noise. This is just layering the noise kind of. And bring up the frequency here to 1.5 and just give it the offset of something. And we just multiply this with this one. And it's very dark now, but that's fine. So then we can do a displace along normal here. And we put this into the scale or amount maybe, and we plug this into the position. I don't think you need to do this. It's kind of random. Some VOPs I think you need to do it, but then we don't need to do it. So let's just discard the color and see what it looks like. So it's a little bit randomness to it on some parts not. I think we're gonna bring down the scale here to 0.5. So it's very, very little randomness, but it helps. We can also maybe smooth this out a little bit as well. And you're free to do whatever you want here. I mean, but you could follow along and then go back and change it to something better, because I mean, this is probably not. It's not that much visible things. We're gonna drop down a group here, and we're just gonna have it over points to start off with. We're gonna call this body. Later on, we will need more things. So this is basically what we want to do here. We will later on drop down this into a VDB from polygons, and we could do it now, so we have it started off. This is still like, yes, you can skip this modeling part if you have a model already. I mean, that's probably a lot better idea. We will need to bring up the resolution quite a lot, because when we do this, in order to get it cool, we will have a lot of polygons, a lot of tetrahedrals. So this is quite high res, 12 millions. I mean, you can do whatever you can handle, but you see there are some smooth somewhere and not somewhere. That's the AI noise coming in, and yeah, I think that's fine. So yeah, let's move on to the arms, which is a bit more tricky. We can just do like this and call this, sorry, what the fuck? Sorry. Yeah, there we go. We can just call this body. And then we go and look at the arms. So we drop down a line first, which will be our arms. We make this a little bit longer, 1.5, and we give it 50 points. Let's see how that looks. Yes, cool. Like that. We drop down a wrangle, because we want to give this UVs, or kind of UVs. So we're just gonna do F at U, and we're gonna float the PT num, this is point number, and we're gonna divide that by the floated num PT -1. And that, as you might know, gives us a value between 0 and 1 running over the points. Since start on 0, you need to subtract 1 from the num-pt. Very simple stuff. Then we're gonna drop down, we can say give UV, give U. I'm very bad at naming stuff. I'm also gonna do a shift S. What the fuck? Sorry, just did this. I like it better. Shift S. Took me a long time to figure out that you could change the wiring. I think it looks nicer. Then we're gonna drop down another wrangle, and we're gonna call this set p scale. Remove the capital letters. Set p scale. And it's quite basic as well. We're just gonna do a very simple thing. We're gonna do f at p scale, and we're gonna say that is equal to a channel ramp, and that we're gonna call p scale, and we're gonna use our u attribute in order to do it. And then we're gonna multiply that by channel multi, so it just gives us a multiplier for the whole thing. It's no harder than that. We're gonna drop in some values here, which might change later on. We're gonna say 0.3, and here we define the shape of the arm. So we're gonna, first off, we're gonna do this as B-spline, and we're gonna set them on both. Then we're just gonna do a little bit of randomness to it. It's not that much. It should get smaller in the end. And I want something to drop off a little bit, like that, maybe. Like so. This is just a base shape. That looks like an arm, right? Cool. We could drop on a sweep. And then for the sweep, of course, we will need a cross-section as well. And that's not very hard. We're just gonna drop down a circle. And we're gonna give it only, we're gonna look at it, and we're gonna have it on the voxel plane, and we're gonna make it into a polygon. And we're gonna lower down the divisions, not to 7, but rather to 4. And then we're just gonna do an edit. And here we could just type in 0.3, because that's the bottom point, I think. Yes. And we just translate this up a little bit to 0.7. Something like this. And then we drop down a subdivide. And that subdivide could go up to 3 levels. And we want to where is it? Is it, we don't want it to, yeah, sharpen edge boundaries only. That's right. Then we have something like that. And we could plug it into the backbone. And that gives us something like this. And right now it's inside crap in here. It doesn't really matter, because we're gonna make this into a VDB anyway. But we should probably also reverse it so it looks better, because the normals are on the inside. And just drop down a fuse as well to be safe. I think that's needed, because I think it might, yeah. Drop down a fuse, and then we could just drop down a subdivide to give it a little bit smoother surface. And then we're gonna group these. We're gonna call them arms. And that group is also gonna run over points. These are later on gonna be copied, but now we're gonna look at the sucker thingies. As you can see, we have a flatter surface and a rounded thing. I think it looks okay. And now I get to see the points, because I'm just gonna drop down null so we don't have to see the points. Okay, we still see the points. Hate that. Go up here, we don't see the points. So that's it. Now we're gonna add the suckers, so to speak. You can't really see them that well here, which is kind of annoying, but if we go to our, if I look at my main project, I mean, it depends on the animation, of course, but I think it's cool to add them. They're hardly visible in my animation, but yeah. So basically what we want is to have some kind of sucking thingies here, and those actually also attach to the ground, which is not very visible in my simulation either, but it's a cool feature and I think it's fun to have. So we can do something quite basic here. Since we have this line here, we could basically just transform it and move it to the side and then ray it back on. So I'm just going to translate this minus 0.2, which moves it here, and then we take this reverse thing and we put an array here, but we want it in the other one, so we're going to remove that like that. It's going to save quickly, because if something happens, I don't want that to happen. And it takes a while to save. I don't know why it shouldn't really. So the ray should be over points, and it should be minimum distance, which gives us this, and we can just remove the guide geometry. We see that it's rayed on here. And then we probably don't want the starting points, because they will be inside the body. So just going to put down a wrangle. And I also think it's a way too many points now, so we're just going to do something simple. We're just going to do if. I'm going to use the Modulus function again, which I always like. ptnum, and if you don't know how this works, it's quite basic. It's just, it should not be equal to 0, right? And then we remove point. ptnum. Like that, we get rid of a lot of the points. So you can see. So basically what the modulus function does when you use this what's in English? Percentage symbol. If you do modulus 3, for example, it just counts up. So first one will be 0, second point will be 1, third point will be 2, and the third point will go back to being 0. So right now we say if this modulus function is not 0, then you remove the point. So basically this one gets removed, point 1, and point 2 gets removed. So we're keeping every third point. So we have 50 there and we have 17 here. So yeah, that's basically how it works. And then we're also gonna do if pt_num, we could do an and up there, but or up there, but if it's less than 8, we're gonna remove the point as well. You could do this in other ways, of course, if you don't want to use a wrangle, but yeah, it's quite simple. And here, then we can say remove points here. And what we want to do then is we also want to set the p-scale for these. And here's the thing, we want them to be smaller. The smaller p-scale is on the main thing. As you can see here, we have smaller p-scale up here, of course. Look at there instead. And then you want these to be smaller as well, because else they can't fit. But we don't want them to be super tiny up there and super big up here. So what we're going to do is we're going to use the power function, which is just equals it out, so to speak. If you keep it on less than 1. If you keep it on more than 1, it raises the contrast if you have something normalized. Hope that makes sense. So we're just going to do p-scale equals at power p-scale. And we're going to do 0.7. And then we're gonna divide that by 10 plus something random. So we do a random function, random at pt_num, and we're gonna add a little bit to that one, 0.5 maybe, and then we're gonna divide the whole thing by 200. Yeah, we'll come to that. We will see when we get to the. We can just do an add here to keep the points, but delete geometry because we don't need a geometry. And then we can do a little bit of point jitter. And this should be super small, 0.007 maybe. Sorry, I kept over. No, that's one too many. Like that. So just give them a little bit of movement, and then we can drop down a couple of points. And this is going to be the backbone. The target geometry is called here. And then we're going to do something super simple for what we copy on. We're just going to drop down a sphere. That sphere could be we're going to make it a polygon. We're going to look at it and bring up the frequency to don't need that much, maybe 7. We're going to have a lot of these, so yeah. Then we can transform it. And what we're going to do is we're just going to move it a little bit, 0.5 maybe. We're going to rescale it, maybe 1.3, 1.2, and 0.7. Something like that, I think, is fine. If we look at this, yeah, I think that's good. And then maybe uniform scale a little bit less as well. Like that. That's good. So we just cut in a little bit. And then we drop down a boolean. And this boolean should just subtract A from B. And that gives us this, which I think is fine. And then we can group these. And once again, we can call this suckers, which I think is a fun name. And we run it over points. then we can plug this into the copy to points. And we have these, which is what we want. We can remove the template here. So then we can just merge these two. And that looks off. Yeah, we just need to rotate this, of course. Just gonna see if minus 90. No, I said minus 90, but it typed 90. So that's good. Okay, so now we have this arm, and what we're gonna do is we're gonna copy it all over the place. So it's gonna drop down a transform node, and this first transform should, we're just gonna translate it 0.9, so we get it out, and rotate it 90 degrees, so we get it like that. And that's good. And for our first row, we have 3 rows in my previous setup, and we can keep it at that. You can add as many rows as you like. It's just fun. Just gonna rotate a little bit, because we don't want to start at the same place for all of these, so let's do it like this. And then we're gonna put down a copy and transform. And this, we're gonna add a total number of 10. And of course we want to rotate it, so we're just going to rotate it 37.75 degrees. And my numlock was off, so it doesn't really want to type here. Okay, now it works. No, it doesn't. No. Okay, sorry, 34.75. There we go. Awesome, a lot of arms. And then we're just gonna do another row. This is like the main thing, so we can do like this to make it clear. We're gonna take another transform here. Move here, and this will be upper row. We're just gonna, there's a small tweak here which I've done before. So 0.2, we're gonna move this to 0.4. We just want to have this highlighted as well, so we can see what we're doing. Slip it out. I'm gonna rotate this 27 degrees, and I'm gonna scale it down 0.85, and then it's on the inside as it should be. So that's good. We're gonna drop down another copy, and this copy we want 12 instances. And that's a bit easier on the rotate, right? It's just 30 degrees. Good. We can start merging these as well. Not meta groups, but a merge. So there we go. We have 2 rows. And then the third row. Just gonna drop down another transform. You could probably do this a bit more efficient somehow. It's gonna do minus 0.25, because we scale it down later on, and plus 25, not 0.25, 0.25, and we're gonna rotate it 27 degrees this time, and we're gonna keep it at 0.5. So these are the small ones. I think that's it, and then we drop down a copy and transform. And for this one we want a little bit more instances. We do 15, and here's the thing, we're gonna do more than one way around it, so we get these groups of 3 here. So that's good. We could merge this down as well. Here we have them. It's not maybe the best thing I've ever done, but it is what it is. Cool. And now what we can do is we could also make this into a VDB from polygons. We have our other VDB up here. We should move down a little bit, and we should group this as well. I'm sorry. I'll call this arms. And we could of course do an inside thing here, which we can call suckers, but I don't know. Sucker geo. Make it another color. Make this another color just to be a bit more precise. I just do random colors. I know maybe I shouldn't, but I like it. So good. Okay, so we're just gonna make this into VDB as well. One thing I just realized, I want this to be called density all over the place. It's just laziness, because when you drop down a volume bop, you have density as the default output, which is, you don't have to drop down a bind. So we're gonna do the same thing here, VDB from polygons. And I'm gonna keep this high res to start off with, because we can do it low res later on when we do the remesh. And yeah, it's like the modeling thing, and it won't be that big a deal. I just plug in the other VDB from polygons, because that gives us a reference VDB that we keep the scale from. So let this cook a little bit. So this will be the first tutorial where I actually go through shading and things as well, because I think it could be fun. And this looks like crap. Why does it? Is it because of these? Okay. That's strange. Oh, no end caps. Sorry. No end caps. We need to go back to the sweep and add end caps. And that should make it work, I hope. It takes a while to cook. Yeah, that's better. So what we're gonna do here is we just gonna drop down a volume bop, which is a very awesome thing, I think. I really like it. It's so easy to give someone that can model for shit something that's a little bit more fun. And it's also the lazy way, and it takes a long time, and it's, yeah, not really what you should do probably. Just gonna see, did I change this to density again? No, I forgot to change the density. Keep it at density. And it has to recook, of course. And I just realized we need something else, because we're doing a volume bop. And this is computer heavy, of course, and if you don't have a decent computer, you will have to bring this down. But I do it. You just bring down the resolution. It's super fine. We don't need a resolution at all. We're gonna take down resolution anyway, because we can't really handle the full resolution if we want a render that's on decent time. But yeah, I'm still doing it high res, and then you can change. I mean, it's easier for you to go down in resolution rather than go up, I think. So yeah, now we have more exterior voxel bands, which is really important for this thing we're doing. So what we're gonna do is we're gonna drop down a unified static. And we maybe should change the mouse up here, because it's kind of slow otherwise. And we're gonna drop down the AA noise as well. And the AA noise is just for pretty much giving us a scale. So we can start off with the AA noise, I think. And that's very basic, it's just a position. And then we fit it to something that's in the like regular 0 to 1, because the AA noise goes from minus approximately, it says 0.5 I think, minus 0.5, but in my experience it's rather like 35 or something like that. Maybe 0.4 here. So we just get that as a scale, and then we can just multiply the static noise with that. And it takes forever. And then we should of course plug in position here. And you can do a lot of these things at render time as well. It's very much up to you how you want to do it. I'm gonna do Verily Cellular, and I'm gonna do a hybrid terrain, and I'm gonna bring up the frequency to 18, maybe 18 point something, just to be precise. doesn't really matter. What we're gonna do as well is we're gonna do a subtract, which is kind of strange because subtract rather gives us additions to the. Can you just plug that in? Okay, you don't want to. Gives us more outside polygons rather than an add. That gives us more inside. It's kind of strange because it's a surface VDB, so it's 0 on the surface, which is compared to like a fog VDB, which goes to 0 where it's goes to 1 where it's actually is something. This one goes to 0 and then it's negative and positive depending on your inside and the outside. So yeah, we're just gonna add this here and let it cook. And this will take a little while. Fast forward. So of course this was way too much. Sorry, we should have a multiply constant here, which I completely forgot. And I'm just gonna take this down a lot, because otherwise it can't handle. So we'll do like that, and we'll do like that, and now we'll let it cook again. So that's good. We have something that looks fine, I think. It's a little bit cellular, and it's a bit random. Yeah, you could do fancy things with just using the overlay instead, and you can get like random for each cell, etc, etc. But I think this is okay. And what I'm gonna do now is, I actually realized I'm gonna step back on my idea of doing this high res. I'm just gonna do it low res, and then when we're done, I'm just gonna change it to high res. So, but the thing is, it's hard to see what we're doing, so maybe we do something that's in the middle. Maybe do 0.1 instead, so it's okay time-wise. It's not super fast, but it's not super slow. We get something at least. That's good. So yeah, we're gonna combine this with the other one. So we're gonna drop down a VDB combine, and we're gonna do SDF union, and we also want to have this one. We're gonna back to this, and we're gonna do a smooth again. So as you see, we smooth this a lot. So the first things, this just gives us a little randomness. It doesn't really matter that much. We're gonna even bring this up more, so we're gonna do a lot of smoothing here. So it is a little bit random, but it's very little. And then we do pretty much the same volume pop. We can just steal this, drop it down, and we're just gonna go in here, and we're gonna change the frequency a little bit down to something along the lines of 10.2, and gonna give it a little bit stronger, and yeah, that's fine. We will of course have to give this one as well a lot more, so we give it 9 by 9 or something. So that's good. We can drop this into the VDB combine as well. Oh, okay, sorry, wrong input, but doesn't really matter. Here we go. Now we have our model. And what we want as well, that I had last time that wasn't that visible, you can see it in the start, but just gonna bring up my final render here. So on my previous version I had these things as well, these small ones down here, and these I skipped these because I don't think they will be visible and they don't really add anything. I had an idea that's gonna flap and give it movement, but it was, yeah, I skipped that idea later on. But I'm still gonna add these small things down here because I think they're funny, and you can do if you want to. I think they're quite fun. So yeah, I'm gonna do that. You can just skip this part if you don't want to have it. It's super fine. It doesn't do anything for the simulation. It's just a little bit of, yeah, you know, fun. So what we're gonna do is we're gonna take the base mesh. We're gonna give it another stream here. Just do a null. I'm just gonna hide whatever's templated. And we're just gonna give it I'm just gonna group this, and what we want to do is want to group this by normals. We can call it normal group. I don't know. So we're gonna do this by -1 and 0, and we're gonna lessen the spread angle to 60. So we have our potential candidates there. And then we're just gonna blast this off. And we're gonna delete non-selected, and we get that. Since we will operate over the points here, we're gonna subdivide it. See how much we can handle. Maybe we shouldn't go overboard with this. Maybe depths of 2 give us a lot of polygons. Yeah, we could probably handle depth of 3, but we start with this. Then we drop down a point VOP. And what we're going to do here is we're going to do a Voronoi noise to give us some kind of cellular pattern to take these out. So, okay, let's do that. Let's drop down a Voronoi noise. Why is it slow? Voronoi. Position. And we also want a frequency that's based on our Y component. So let's get vector component and just fit it. And we're gonna fit it from -0.8 to 0.2. And you can see what that gives us. If we just plug it in here, we get something. It's hard to tell, but we're just gonna bring this up because this is for the frequency, so we bring it up to something like that. You will see later on how it looks. And then we want this to be a vector, so we're just gonna do a float to vector. I'm just gonna plug it in all three those, and then we're gonna plug this into the frequency. And the cool thing with Voronoi is that we could use the seed here as well to do some random things with it, which I think is fun. Let's fit this Voronoi distance 1. And we're gonna fit it from 0.1 to 1. And then we're gonna take the seed here, do a random, and we're gonna refit that, because this will be our maximum. So we're gonna refit that from 0.25 to 1. And then we plug it into destination max. And then we're also gonna, sorry, we're just gonna make this a little bit clearer. We could also take our Y component, which we have here, and fit that. And what we're gonna do is we're gonna fit it from -0.8 to 0.2 again. And this will then be added. Okay, this is not very nice at the moment. Let's just move it away a little bit. Like that, and move these up here. Like this. And yeah, the two fitted ones I'm just gonna add. So we're gonna add that and add that. And what that gives us is something like this. So we have random. The cells are random, which I think is good. And that's that. We used the color here, I think. We're just gonna give this thing normals on the point level. And then we can very easily just blast off everything that's at CD point R is less than 0.1. And should run over points. Okay, so we got the wrong component here. We should get component 2, of course. And then we should take that component and put into, let me see here. This one should of course have that component, I think, right? No, sorry. Here's the value, it should come from that one. There we go. And now if we blast it, we get these, which is what we want. Small little dots. See, they're kind of random. I don't know if it matters. We could, of course, do subdivisions on one level higher, which will take a little time, but it's not that hard. I mean, it's a one-time operation. We could just save it afterwards, cache it out. So it's depending on what you want. You get a little smoother results, which is fine. Cool. We're gonna recompute the normals on point level here. Then we're gonna group these. Let me see here. I'm gonna group. And what we're gonna do is just group and not group include edges and unshared edges. So we get a group of that. We're gonna call it edge. And this should of course be over edges. We call it edge. And then we're gonna do undissolve. And we're gonna use the edge group. And we're gonna delete non-selected. Remove inline points. What did happen there? Yeah, we got it down quite a lot, as you can see. And then we're going to drop down connectivity on primitive level. As you can see now, we have, just to show you, this is what we have now. So we just removed a whole bunch of shit. Yes, so we drop down our connectivity. And we're going to do it over primitives. We can just give it a name. Yeah, let's call it name. It's fine. And then we're gonna do a little for each loop. Each one of these. So we do a for each named primitive, and what we're gonna run over is name. And as you can see, we have 142 here, which is fine. First off, we're gonna do. Drive in here. I'm going to do a single pass because it's always easier to look at single pass. We have one of these small ones. It's hard to tell. Maybe we should just highlight the base as well so we see where we are. Maybe we shouldn't. Sorry. Do it like that and move down here so we see what we get. Man, for fuck's sake. And now we see everything. Why is that? This kind of just happens sometimes. We're going to take a new scene view. And wait a second. And we get it right. And now hopefully we can just do it like that. Cool. And we step in here, do a single pass. And we're going to see where we are. That's good. It doesn't matter that we are on the inside. So the first thing we're going to do is put down a measure. I'm also going to remove the template because it annoys me, sorry. I know it's a bit back and forth there, but I don't care about the template right now. I know we're at the right place. So we're going to measure, and what we're going to measure is the area, and we don't really have to do anything as well. We just output the area attribute. and we can then just attribute promote area original class primitives, new class points, and we are fine with deleting the original. So then we're gonna extract the centroid here. So we get just a point from it, which is in the center. And we're gonna move this a little bit. So we're gonna move this so we center this as well. So we just put down a little script, h script, and we just gotta do minus dollars, and this is just saying subtract the, so we get it centered. Oh, we don't. Why don't we do that? Is something wrong? Ah, minus, sorry. Minus Z as well. So now we have a centered thing, which is useful. Then we want this to be pointing downwards, so we can do our thing. So we're gonna drop down another point VOP. And in here, basically what we can do is we can take the normal. Let's gonna see. We have point normals, yes. So good. We can just make sure that it's normalized. It should be. And then we can take our constant and make it free floats. And what we can do here is we can take the cross product from these to the normal and our constant, and that gives us a perpendicular thing, a perpendicular. It should give us a perpendicular. Maybe we need to. Oh, the thing is, I think we have to do like this actually. Sorry, we take the input here because I think this might read the vertex normals. So we take import. It shouldn't really. Just gonna do it like this, see if it's different. No, it's the same result, I think. Okay, fuck it, we do this anyway, just to be sure that we have the point attribute rather than the old. So I was gonna see if this works. It should work. So we're gonna normalize this cross product, and we're gonna do another cross product, which is this one and this one. Let's see how that looks. And it's perpendicular to the other one. I'm kind of annoyed that. Good. Let's see here. So the first cross product looks like that, and this one is perpendicular to that one. I think it's right. So we then can normalize this, and we can do a vector to matrix. And we plug this in the first one. We plug our normalized normals in the second one, and we plug our first cross product in the third one. And then we just invert this. And we multiply our position by this. And hopefully this works. So I can explain a little bit what I did afterwards. But basically we're taking how the thing is rotated and invert that, and as you can see, we now have something that's pointing upwards. So the good thing is this would work with every single one of them. So basically what the normal is telling us, since it's centered, is if we remove this, you can see its normal is pointing where, how it's turned. So if we then we could also do like this. We could bind export this. So basically, if we call this O, I like to call it that, orientation, and we say it's a 3x3 matrix, and we add a visualizer for it. O, O, O. You can see what it's saying is this. So this is basically a matrix telling us how we are rotated. And it works as long as, as long as you don't move over the up vector. So the first normal just tells us one direction, and then with the cross product from the constant you can get two perpendicular vectors, and those three could be combined into a 3x3 rotation matrix. If you then invert that and multiply it, you will get the inverse transformations on your position, which is exactly what we want. So yeah, that gives us that. So that's good, and now we can easily do things with this. We're gonna attribute transfer here anyway. We're gonna take this, and we're just gonna do points. We want the normal and the area, which we should really have already, so I'm not sure. No, we lose that when we do that. Okay, that's why. Sorry. So now our centroid has those values as well, which is good. That's why we did it. Sorry, I'm confused. And then we can do a copy to... Sorry, we can move this down. Now we can have a copy to points here. And we want that one as the geometry. It's going to do like that. And we're going to bring in a line. And we want 20 points. And here we're going to do, we want this to be depending on the area. So we're going to do a power function of the area. So what we're going to do is area, and then we're going to call for the point. And what we want to do is we're going to look at the attribute transfer. And we want to look at, let me see here. Let me see, returns the value surface node point number. I want to look at point number 0. You want to look at the attribute area. And we want to look at this like index 0, yeah, because it's not a vector, so it's fine. And then we're just going to do that by 0.5, so we get the same kind of thing where it's a little bit less contrasty, so to speak. We're going to multiply it by 5. And then we're going to copy it to points. And that's working. And then we're going to give this a U as well. So put it on a wrangle. So f at U equals to float, very standard operation as always, pt num, and then divide that by float at num pt minus 1. That's fine. That's fine. And I'm not sure if we can use this, but it's good to do anyway. Yes, and then we take our point VOP and we just transform it and we rotate it 90 degrees. So that gives us that. And then we use this as for a sweep. So sweep and that gives us something like that, which is hard to tell because we're not sure where we are. And we're gonna do scale along curve. We can do something like this maybe. And then we're gonna look how this looks for everyone. And it seems off. It seems like something should rotate. I think the line should be, of course, in not Y, but Z. There we go. Here we have these small little things. We should, of course, add normals to it as well. It have very strange normals. So yeah, this is what we get. We want end caps on the sweep. And we don't want to show material here. It's still very dark. I guess it's because inside stuff. It doesn't matter because we're going to do VDB from polygons anyway. But basically, yeah, that's it. It gets a random size, it gets bigger down, and I think it's actually a decent setup here. Yeah, I think so. And then we're gonna, I don't know if I should explain it more because it kind of took a little bit of tweaking to get it right, but yeah, I think you understand. That's good. Let's move on. We do a VDB from polygons. And just gonna plug in reference the other one. There we go. So we have the same. And we're gonna do a VDB smooth. And I'm not sure if we can handle this with this low resolution. So yeah, that's a problem with the resolution right now. Because this only gets 139,000 voxels. So maybe we need to bring up the resolution a little bit. Let's do like this just to see what we get here. Yeah, at least we're getting something. So that's good. That's good for now. We're gonna reshape this. Gonna make them a little bit fatter. VDB reshape SDF. I'm gonna dial it in 4, which will probably be a bit exaggerated now with this resolution. And then we're basically gonna drop in the same volume up but change a little bit of it. So we just take this, copy it here. And what we need to do here as well is call this. Let's save this. Yeah, okay, so saved, good. I'm gonna call it density. Why is it not? Did you think something went wrong here, I think. Okay, I'm gonna save and try again. Okay, I'm gonna restart Houdini. So I'm just gonna go through what we actually did here because I felt like I maybe went a bit too far. So let's go back and look at this for a single iteration. So what we're doing here is we have our kind of backbone for the sweep, but it's off. It's rotated randomly. So what we do then is that we measure the area in order to get the size of the sweep, and we then make this into move this into the center. And what we do then is we look up how it's been transformed, and we can do that with help of the normal, since the normal is the same. It's pointing outwards, so that gives us the center point. We then rotate this to have it working for the sweep. At the same time, we look at the center point of this, and we extract that centroid. But when we extract centroid, we could use transfer attributes here instead. I don't know why I did attribute transfer, but it doesn't really matter. We do an attribute transfer to get those back. We now can use this to copy the points, and that gives us a line for each point using the normal. If we were to skip this, you see it doesn't work. We need to have the normal. We then set a float value, which is not really necessary right now, but I think we might need it later. I think I want it later on for shading. I think that's why it's there. And we then sweep. And since we now have the backbone centered, it's all good. So that's basically it. I don't know if we could... What happens if we do rows and columns? No, it's not better, it's just chaos. I just wondered if we could skip the props. Never mind. So that's what we're doing, and we're doing that for each and every one of them, which gives us this. And we then do a VDB from Polygon, which kind of fucks up the small ones, I think. No, it's kind of okay. And we go down and do a volume bop, which looks fucked up, because that's kind of how it is. With this lower resolution. We're gonna change some things here. We're gonna go up and bring up the frequency. At least to not 30, maybe 23. And I think we're gonna have a less of a, since it's smaller, we're gonna have it a little bit less. And that's fine, I think. It's hard to tell right now because it's a bit low res. What we can do then is that we can combine this with other ones and see how it looks. So we're just gonna copy this video combine. We're gonna plug this one in. We're gonna plug this one in. Then it has to cook the other ones as well because I restarted Houdini because it went crazy. So this looks a bit off, but yeah, it's fine. It will be fine. So what we're gonna add now is something. You see here that this is not very good. I mean, you could smooth this out, but it still won't be. I mean, we want something here to cover where it's over, and same thing down here. We want something to like just give us a little bit of some kind of geometry that lives around the intersection between the objects. So let's take a look at that. We could also just, let's do it like this. Let's do this whole thing and put it inside a box and call it small bottom stuff. Yeah, make it a color. Let's make it pink. That's cool. So we're gonna take the base body. We can do it to make it a little bit easier. We can do a null here, which we call out polys base body, just to have something. And we can just object merge it down here instead. Gonna put it here, I think. So we just bring up that one. So we have it there, and we still see the annoying stuff. What the first thing we want to do is we also want to bring in these. And I think we can do this without any hassle. So we're just going to do a wrangle here, because we want to mask around these. So we're just going to do a very simple thing. We're just going to say mask at mask equals to 1. And then we can do a simple attribute transfer here, where we plug this one in and this one in. And we can just transfer mask. So that's good. Now we have that. We should of course change the conditions to something very small here. So we just get it around those. Then we can do an attribute blur as well. I think that's good. And we can just do like 50 iterations and we can call it mask. And we could visualize this to see how it looks. And okay, of course, upside down. So we get that. We kind of don't get. We kind of want it on. Sorry, we actually want it on. We want it on the lower part as well, I think. So we're just gonna do an object merge here as well. Before we do the VB, we can do null here. I'm gonna say it out bottom polys. I think I changed how I call it. Fuck it. Doesn't matter. We're gonna bring that in as well. I like to do object merge because it's a bit cleaner. You don't have to have things going all over the place. Just merge these two together. Yeah, that's fine. And now we have these smallest as well. I think that's good. And then we can do like a ramp thing. We can do it like this. We can put down a wrangle. I'm gonna keep these. I'm not naming things correctly here. I can make this so it's easy to go back. Mask wrangle, mask or shramp. So we're just gonna do something like at mask equals to shramp mask. Yes, mask and at mask has to be. And what that allows us to do is something very simple, which is this: up, and down. I'm gonna remove the color here, and we're gonna put the color here instead. So yeah, we need to tweak this a bit more. Tweak this a bit more. Something like this maybe. We get inside here as well. Just fine. We get some things down here, but I don't know if we want to tweak it more. Maybe I want to tweak it a little bit more here. See if we can get a little bit of holes here as well. Yeah, I think that's good. Something like this maybe. Yeah, I think that's good. And what we could do then is we could probably do something like I don't know how much I can we need to subdivide this, I think, because we're running over points. So just gonna do a single subdivision. It gives us quite a lot of polys, but that's fine. And we're gonna put down a point crop to give it a little bit of randomness. And inside this, we're just gonna bind in the mask. And we're gonna bind export the mask. And we're gonna do a Baroni noise. And we're gonna add the frequency. Just gonna look at that looks. Bring that to CD. There we go. And we're gonna fit this. And we're gonna do something like bring it up to, bring it down. Sorry, bring it down to 0.9. And then we're just gonna multiply these. So we have these things. Maybe with a bit too hard, maybe bring it down to 0.5 here. We have something random along these edges, which is good. And then we bind export it as well. And then we could simply just blast off at mask is less than 0.7. And of course we need to run this over points. And we get these things. And I think it's too harsh here. I think we need a lot more. So we're gonna go up here and tweak this. We're gonna keep a lot more of the inside. Just gonna go up here and look at the color. I think we need to do like this water. Not that much outside, that's getting killed. Let's see what we get now. Yeah, I think we should do this the other way around. We can bring it up to 0.6, but we're gonna get the inverse. So we want to get that. Sorry, was a bit off on that, which is cooler, I think. And maybe we can bring this back down a little bit then. Yeah, let's see how that looks. So we blast this off, and we have this, which is pretty much what we want. It's a bit random, but it's good. We have a lot of points, and we can do a VDB from particles here, since we don't have it extruded. And yeah, that turns into a blob. So point radius scale 0.1, and then bring this down as well. We can just do this at high res from start, because it's not that high res anyway. So then we give something like this, which is good. We could do a VDB smooth, SDS, FDS, SDF. And let's be quite harsh on this one. So Gaussian is a lot harder than mean value. And bring it up to 2 voxel. Yeah, there we go. Keep some of it. And then we want this to grow a lot. So we're going to reshape it. And we're going to give it a lot of more size. Let's bring it up to 16. It'll take a little while to cook. There we go. I think I'm gonna smooth it a little bit less, take it down to 2 iterations. Keep a little bit more, because I think I lost a bit too much on my last thing. There we go. And then we're gonna bring in the same volume warp as we had before. Just gonna copy it, but this one will be quite harsh. Sorry, we're gonna do like this, and what we probably need to do here as well is just gonna skip the AI noise here, bring this up to maybe the double amount approximately, and see how that looks. Oh, classic. We're gonna call this density as well. You could of course bind and bind export, but I'm too lazy for that. I'd rather just let it cook for a while and don't have to do any work. So that looks quite off, and yeah, we need more half band voxels. So we're gonna bring this up to 12, and that will take forever to cook, but it's fine. It's just a one-time thing, and then we're done. The reshape takes some time, but there we go, and now I think we have something solid. I do think so, yeah, it is solid. So that's good. And then we can do another VB combine down here. Combine. We're going to do another SDF union. We're going to let this cook. So yeah, that looks kind of odd, but we're going to smooth this anyway, so I think it's good. So now it's just a few minor things left. We just gonna do a new smooth to make it a little bit more. We're gonna bring up 2 and 3, and we're gonna smooth it. It takes a while. So yeah, it's very smooth. We have some of the things left, but the high resolution it will be a lot less prominent. And then we're gonna bring in a copy of this one. And we're gonna plug it in here. So we get a bit of noise that adds to anything. But the thing is, we're gonna bring down the multiply constant a lot. I'm gonna bring it down to 0.1, I think. See how that looks. That looks better. And we're also gonna bring down the frequency to. Okay, I'm gonna do mouse up here. Into auto update. So let's bring this down to 13. We'll go on that. Also makes them look a little bit more integrated, which I think is really good. We could also actually do one more before we smooth it, which is a little bit harsher. We could. Oh, I accidentally put 2 there, but oh, we don't need that multiply. Do we have a multiply down there? That should be removed, of course. So up here we could do this, like maybe just to bring it all together a little bit more. We kind of ruin our squid thingies, but hopefully it will work when we have high resolution, because now they're kind of ruined, which is sad. So maybe we shouldn't do that. It integrates it more, but it kind of fucks it up as well, so yeah, never mind, we skip that. And you don't see them that well here anymore, but they will come back when we have high resolution. So what we could do is we could do a convert VDB like that, and we convert it into polygons, and we file cache this. And this will be a high res. So we're gonna save current frame. We're gonna remove hip name because that makes it slower, because when you save it changes and have to recook. So we're just gonna do operator string. We don't need that, and we're just gonna call it final poly model fat skin. And what we're gonna do is we then gonna change the resolution back to where we were. And since this is referencing everyone else, we can bring it down to 0.25, and hopefully it will work. And this will be a high-res thing, and if you can handle it, it's good. Otherwise, keep it lower res, because we will have it lower res, and then maybe go down on the smooth as well, so we don't fuck the suckers up. And we're back, and as you can see, we actually have the things left. And we have, I think, something that looks decent. So we're just gonna save this and load from disk. So this is very high res right at the moment, and we need to do something about that because we can't really handle that in the solver. It's 7.5 millions, which is a bit too much. So what we're gonna do now is we're gonna group all our things again, because we lost the groups. Basically what we can do is first put down a primitive group and run it over primitives, because this is all skin fat, so let's do that. Let's call it skin fat. Then we want the arms, so we're gonna do copy this group. We're gonna let skin fat and underscore arms. And we want another group called suckers. And we want another group called, sorry, we should actually have not plugged in. We're gonna have another group called body. And what we're gonna do for all of these is just keep it in bounding regions, run it over points. This one could, however, we could run that over points as well. Although it should be primitives in the answer. No, let's keep it at primitives. So the skin fat arms, we could just bring in our what we could do here is we could do a null here as well, so we have this easily accessible. Null, we're gonna call it poly skin arms, and we have our base body, so we don't have to care about that, but we also need our suckers, and not that, sorry, suckers are here. So we need to, that's what we need to do here. We have this skin poly arms, and we can do a blast here because we have grouped this, so we can just say suckers, delete non-selected. We have these. We're gonna do a null here as well. Poly skin suckers. So good. So now we can do an object merge here. We can bring in. We first want the arms, so we bring in that. And the easy way of doing this is just doing VDB from it, I think. So we do VDB from polygons, and we up the resolution a little bit. We don't have to be excessive here, but you can do something like that, I think. It'll be fine. Yes. And then we do a reshape as well, just to get a little bit bigger. Maybe 2. And then here we can just do bounding volume and plug that in, and we get these. So that's good. We can do a similar thing, but just bring in the suckers, plug that in there, and do bounding volume, and that will give us that, which is good. And then we can do similar thing with the body. We should of course call the other ones polys as well. And there we will have bounding volume, and we have this. And we don't have anything for those. I don't know if we care about that. Could be cool to have for shading, so let's do that as well. Let's bring in another one. Let's bring in that one. And we could probably just take this. It's so close. Let's do like this. We have to reshape it as well. Okay. I hate when you press on the line because it always fucks up. Hello, let me get in on that. Okay. Put it. Okay, that's annoying. And let's direct it to 2. Give it one more to be safe. Yeah, I think that's good. So that's good. We have all our groups. What we want to do then is we just want to convert this into to attributes instead. So we're gonna do a wrangle. So we're basically just gonna put down some lines. So we're just gonna say if group underscore skin fat arms equals to 1, f at skin fat arms equals to 1. So we need an at there, of course. We can just copy this, and we can just, sorry, we need to change the name here as well, of course. Do it 4 times, and we need, of course, call it this skin fat. I don't know what it's called. It's like transition blob. That's a long word. We call it blobs. So we're just gonna do skin fat arms. We're gonna do skin fat suckers. We're gonna change skin fat suckers. We're gonna do skin fat body, skin fat body, and we're gonna do skin fat blobs. We're gonna do skin fat blobs. So that's good. Then we can do an attribute blur. And we're gonna do a lot of iterations for this. We can do skin fat body. We're gonna do skin fat arms. And we're gonna do skin fat blobs. Did I spell that with 1? Yeah, I did. We're gonna do 400 blurring iterations. And that takes a little while to cook. And then we're gonna do a copy of this. We're gonna do it over suckers. I'm gonna save. So we saved, and we're just gonna do blobs, and we're gonna take it down to 30 iterations. So that's good. Oh, my wife is constantly sending me things on Messenger. I should probably check that out, but yeah, we'll do it later. We can do a color here just to check that it works, and we can look at the different attributes. So skin fat arms, here we go, and we have the body, and we have blobs. So that's good. Those lower ones are also not in any group, but that's fine. I don't really need it right now. I don't think we're gonna do anything special with those. We could add those as well, but I don't think it's needed. So yeah, we could, about here we are done with the body part. So let's do the muscles, which is very similar but a lot easier. Yeah, I will be right back with that.